Let's solve the equation negative 72 n squared plus 200 equals 0. Okay, this is a special case of a quadratic equation in that we have the squared term and we have the constant term, and that's it, right? We're missing that middle term that has n to the first power. Okay, and so we have two strategies to solve this type of equation. Okay, the traditional factoring and use this zero product property is available. We can do that. If we decided to do it that way, let me rewrite the problem here. Okay, I'm going to look for a common factor between negative 72 n squared and 200. Those are both divisible by 2, 4. They're both divisible by 8. Both divisible by 8. So I'm going to factor out an 8. I'm actually going to factor out a negative 8 because the first number here is negative, and usually it's just easier to factor it out. That first digit being positive is usually a little bit better. So if I divide this by negative 8, if I factor out a negative 8, I'm left with 9n squared. If I factor this one, factor out the negative 8, 200 divided by negative 8 will be negative 25. Okay, so we have negative 8 times 9n squared minus 25 equals 0. All right, well, I want to get rid of that negative 8. I'm going to divide both sides by negative 8. That'll cancel it right on out. And that will leave me with 9n squared minus 25 equals 0. Now, I recognize that this is difference of squares. Something squared minus something squared equals 0. So I can say 3n squared minus 5 squared equals 0. Okay, I don't usually write that step out, but that's what I'm thinking. So there it is. 3n squared minus 5 squared equals 0. Remember, difference of squares says if you can write it like this, then it will factor, without actually having to work it out, as 3n plus 5, 3n minus 5, right? You just put those values, well, that was wrong, like that, with a plus and a minus. Okay, equals 0. Now I'll go ahead and use the zero product property, set both of these equal to 0. Subtract 5 from both sides. 3n equals negative 5. Divide both sides by 3. N equals negative 5/3. And then I'm going to work this one out as well, but I'll just get a positive 5/3, right? Add 5 to both sides. 3n equals 5. Divide both sides by 3. N equals positive 5/3. Okay, so there we go. I could use the zero product property, factor the expression or the equation, and set each part equal to 0 and solve it, right? So that's the usual way that we'll solve a quadratic. The other way is to use the square root property to solve this. So negative 72n squared plus 200 equals 0. Remember, to use the square root property, you need to get n squared by itself. So I'm going to subtract 200 from both sides. Negative 72 n squared equals negative 200. I will now divide both sides by negative 72. And then I have to reduce this fraction, of course. But negative 72 over negative 72 will cancel. I'm left with n squared equals negative over negative is positive, and we know they're both divisible by 8, so we'll divide them by 8. 200 divided by 8 is 25. 72 divided by 8 is 9. Okay, so we have n squared is equal to 25 over 9. Remember the square root property. If something is being squared and equal to a number, then the thing that's being squared is equal to the square root of that number and negative the square root of that number. And don't let the square root of a fraction freak you out. Okay, remember, the square root of a fraction, just do the top and the bottom. Okay, do them both. It's the same thing as having the square root of 25 and the square root of 9, right? You just think about it like that. square root of 25 is 5. The square root of 9 is 3. That should look familiar, right? Okay, and then same thing here. The square root of 25 is 5. The square root of 9 is 3. So 5/3 and -5/3.